Hello everyone, myself CNA sir. I am from CNA'S GAM classes, Bhuneshwar. Today I'll teach you tautomerism. See, it is an important part of structural isomerism. Tautomerism is an important part of structural isomerism. Tautomerism is also called as a desmotropism or cryptomerism or also called as a dynamic equilibrium. Understand? Tautomerism is also called desmotropism, cryptomerism or dynamic equilibrium. See, it is a special type of functional group isomerism. Tautomerism is a special type of functional group isomerism. Okay, it is a special type of functional group isomerism. But what is the special? See, the isomers exist in equilibrium. The two functional isomers are exist in equilibrium and they are interexchangeable. Therefore, there will be a dynamic equilibrium between the two isomers. That's why it is also called as dynamic equilibrium. Understand? The two isomers are exist in dynamic equilibrium. They are interexchangeable. And it is not possible to separate one of the isomer from this equilibrium mixture. So that's why it is considered to be a dynamic equilibrium or desmotropism or cryptoisomerism. Okay. Now, let me go through in detail about this tautomerism. Okay. See, tautomerism arises due to a liable alpha hydrogen atom. Tautomerism is due to a liable alpha hydrogen atom, or it can be called as a acidic alpha hydrogen atom. So the liable alpha hydrogen atom or acidic hydrogen atom means it can be interexchangeable between two atoms or between two groups of the given compound. The hydrogen atom is interexchangeable. So that's why that is taken as a liable alpha hydrogen atom or acidic hydrogen atom. Okay. Now, what kind of functional groups can exhibit this tautomerism? See, like a aldehyde group, or better to say carbonyl group, but it must and should have that alpha hydrogen atom. At least one alpha hydrogen atom must present there. So this is a aldehyde which having alpha carbon and 3 alpha hydrogens are there. So exchange of hydrogen may possible and leads to this kind what you call isomer, right? These two are exist in equilibrium. So this form is considered to be keto form and this form is considered to be enol form. Keto enol. That's why it is a kind of keto enol isomerism. Have understood? The hydrogen atom is exchanged between two groups. So that's why that is the liable hydrogen atom. Alpha carbon के ऊपर liable hydrogen atom है तो that can be exchangeable. So that can be called as acidic hydrogen also. That's why the keto and enol forms are exist in equilibrium and those are interchangeable or interconvertible. That's why it is considered to be keto enol isomerism. Okay. So before going to explain this, let me go through classification of these tautomers. See, tautomers are of two types, matlab dyad system and a triad system. Okay. See, tautomerism is of two types, in which first one is a dyad system of tautomerism. Okay, dyad system of tautomerism. Okay, what is a triad system? Dyad system of tautomerism क्या होता है? See, these type tautomers are because of exchange of hydrogen between two adjacent atoms. Okay, see, it happens due to exchange of hydrogen atom between two adjacent atoms. Therefore, it is also called 1,2 tautomerism. If the hydrogen atom is exchanged between two adjacent atoms, it is called as a dyad system of tautomerism, also called as 1,2 tautomerism. Okay. For example, if you take hydrogen cyanide, this is the best example for this dyad system. So hydrogen, say triple bond N. So this is one isomer, and which is always exist in equilibrium like this. Hydrogen, N, and a dative bond towards carbon. So listen carefully. Carbon, nitrogen. In between these two, hydrogen atom is exchanged. In the first case, hydrogen is attached to carbon, whereas in second case, it is attached to nitrogen. So these two are interexchangeable or interconvertible, and these two exist in dynamic equilibrium. And here it happens between two adjacent atoms. That's why it is called as a 1,2 tautomerism, or also called as a dyad system of tautomerism. 1,2 tautomerism, also called dyad system of tautomerism. The second thing is a triad system. So in the same way you can understand, triad system means the exchange happens between two alternate atoms. The hydrogen atom is exchanged between two alternate atoms. Then it is considered to be a triad system of tautomerism. Okay, listen carefully. Triad system. So here hydrogen atom is exchanged between two alternate atoms of the compound. Right, hydrogen atom is exchanged between two alternate atoms of the compound. Okay, it is also considered as a 1,3 system, because hydrogen atom is exchanged between two alternate atoms. That's why it is considered as 1,3 system. Okay, so previously I have given an example that comes under this kind of system, that is triad system or 1,3 system. That is acetaldehyde, I already given, I think. So acetaldehyde is the best example. So CH3 C double bond OH. So this is the alpha carbon and it has 3 alpha hydrogens. Now this alpha hydrogen is exchanged with this unsaturated system. So it can give like this, CH2 double bond C OH H. Okay. So it contains only carbonyl group. That's why it is considered to be keto form. It contains ene and ol. That's why it is considered to be enol form. So this 1,3 system or triad system is the best example for keto-enol isomerism or keto-enol tautomerism. In aldehydes and ketones we can observe this kind, but they must have at least one alpha hydrogen. Okay. So if you see these aldehydes and ketones, acetaldehyde can exhibit, even acetone also can exhibit this kind of isomerism. I will go through that acetone also. So listen carefully. So CH3 CO CH3, it has 2 alpha hydrogens. So definitely one of the alpha hydrogen can be exchanged with the unsaturated system. Then you are getting this kind. Right. So this is the keto form and again this is the enol form. So acetone also can give keto-enol isomers or tautomers. If you consider benzaldehyde, say benzaldehyde. So is it exhibits tautomerism? No, not at all. Why? Because If you see the structure of benzaldehyde, it is like this. So there is no alpha hydrogen. Alpha carbon is an unsaturated carbon. That's why there is no alpha hydrogen here. There is no exchangeable hydrogen. So therefore, remember, benzaldehyde does not exhibit tautomerism. Okay, even benzophenone also does not exhibit. Even benzophenone also doesn't exhibit this tautomerism. Okay, so benzophenone structure, if you see, it's like this. Okay, here also there is no alpha hydrogen or no acidic hydrogen. That's why even benzophenone also does not exhibit this tautomerism. Okay, so you are telling about aldehydes and ketones, and what are the other functional groups they can exhibit tautomerism? See, apart from these aldehydes and ketones, the other functional groups they can exhibit tautomerism are Nitro Group. Okay, another functional group which exhibit tautomerism is Nitro Group. So nitro compounds having labile, or better to say acidic alpha hydrogen atom can exhibit this tautomerism, right? So nitro compounds having alpha hydrogen atom, that too acidic alpha hydrogen atom, can exhibit. See, if alpha hydrogen atom present on nitro compound, definitely it is considered to be an acidic hydrogen. Then for exchange of hydrogen happens. For example, if you take nitromethane, so this is the structure of nitromethane, right? Now, if this hydrogen exchanges between carbon and oxygen, hydrogen exchanges between two alternate atoms, 1,3 position. So there you can get this kind of tautomer, OH, and this is dative bond. So this is called as a nitro form and this is called as Ac form. Okay, nitro form and Ac form. So these are the nitro compounds. They can exhibit tautomerism. Nitro compounds and can exhibit tautomerism like this. Okay, other functional groups, if you see, cyanides having at least one alpha hydrogen atom also can exhibit cyanides having at least one alpha hydrogen atom can exhibit tautomerism. Okay, so best example you can take methyl cyanide. Say at least one alpha hydrogen, that is the must and should condition, CH3 C triple bond N. So which is having equilibrium with CH2 double bond C, N double bond H. Okay, CH2 double bond CH double bond NH. Okay, so this kind of isomerism is considered to be tautomerism, and the two isomers are exist in equilibrium. Okay, so aldehydes, ketones, nitro compounds and cyanides, so they having alpha hydrogen can exhibit this tautomerism. And one more important point, that tautomerism can be catalyzed by an acid or base. See, to exchange this hydrogen, a catalyst is required. To make tautomerism quite rapidly, we need a catalyst. It may be either acidic medium or basic medium. When acid is used, it is called acid catalyzed tautomerism. When base is used, it is called base catalyzed tautomerism. Understand? So it depends on the medium what we are using. Okay. Now, if you go through few more important points regarding this tautomerism, I'll have you listen carefully. Okay. If you go through Quironoid structures, see, Quironoid structures do not exhibit tautomerism. Quironoid structures do not exhibit tautomerism. Okay. See, if you see some quironoid structures, let me go through some quironoid structures. See, this is one quironoid structure. Okay, and this is another quironoid structure. And there is a kind. So, these three quironoids. Okay, these quironoid structures do not exhibit tautomerism because there is no exchangeable hydrogens or labile acidic hydrogen atoms. So that's why this kind of quironoids do not exhibit tautomerism. Okay. Now, one more important point. The conversion of keto form into enol form is called as enolization. Okay. So, all of you understand this point? The conversion of enol form into, conversion of keto form into enol form is called as a enolization. Understand? The conversion of keto form into enol form is called enolization. See, in some structures, keto forms are more stable. In some structures, enol forms are more stable. Okay, for example, if you take an CH3 C double bond OH acetaldehyde, this is the keto form, and its dynamic isomer is CH2 double bond COHH. This is the enol form. So, among these two, which is more stable form? Obviously, here keto form is more stable when compared to enol form. All of you please listen carefully and understand. Stability of keto form is more than that of enol form. Sir, how? Because C double bond O bond enthalpy is greater when compared to C double bond C. So that is the main reason for this stability. C double bond O is a strong bond when compared to C double bond C. So that's why here keto form is more stable when compared to enol form. In the same way, if you see acetone also the same kind of example. CH3 C double bond O CH3. This is the keto form, and CH3 C OH double bond CH2. This is the enol form. Okay. Here also keto form is more stable when compared to enol form. Again the same reason, the bond enthalpy of CO is greater than the bond enthalpy of C double bond C. Right? Bond enthalpy of CO is greater than bond enthalpy of C double bond C. So that's why that is the stability. Okay. In case of phenol, if you say phenol, C6H5OH. Okay. See, this is the enol form. Okay. And if it's a dynamic isomer of this compound will be like this. Understand? So hydrogen will be exchanged from this alpha carbon and oxygen. So this is the keto form. Enol form and keto form. Here which is more stable? So no doubt here enol form is more stable than keto form. All of you, stability of enol form is greater than that of keto form. Because here enol form is aromatic in nature. Enol form is aromatic in nature. So aromatic stabilization. So aromatic compounds are more stable when compared to non-aromatic. Okay. So that's why due to aromatic stabilization, यहाँ पे stability of enol form is greater than that of keto form. So this is a phenol and it's a keto form, right? Let me go through extent of enolization. What extent the keto form is converted to enol form is called as extent of enolization. सबसे least enolization is observed in acetone. 0.00025% only is converted to enol form. See, no need to memorize these things, but you just memorize the compound. Acetone can undergo very least extent of enolization. मतलब keto form is more stable. After acetone, you better to go through this diketone CH3, CO, CO, CH3. After that, beta keto esters CH3, CO, CO, CH2, COO, CH3. Again CH3, CO, CH2, COO, C2H5. See, these two compounds are considered to be beta keto esters and they contain aceric hydrogen also. After that, CH3, CO, CH, CH3, COO, C2H5. Okay. Next, C6H5, CO. Wait a minute. CH3, CO, CH2, CO, CH3. C6H5, CO, CH2, CO, CH3. Again C6H5, CO, CH2, CO, C6H5. C6H5, CO, CH2, CO, CHO. CH2, CHO, sorry. C6H5, CO, CH2, CHO. And final compound, this one. It is 99.9% enolization. यहाँ पे keto form is very unstable. 99.9% it is converted to keto form. So this is the order, right? This is the extent of enolization. सबसे least acetone and सबसे highest enolization यहाँ पे होगा. It is transformed into phenol. Okay, so that's it. It's about extent of enolization. Okay, so this is about tautomerism. Thank you all.